Okay, today we're taking a look at investigating symmetry and can we show that objects are symmetric about themselves. So in order to do this, what I'm going to do is I'm going back to the age-old our patty paper, our tracing paper. I'm going to lay it down over top of my image and I'm just going to simply trace it on there. Once I have it traced on there, this is going to allow me to fold the paper and actually fold that object onto itself and see, because that's what symmetry is. Symmetry is when I can fold that Y shape on top of itself and see that it does have a line of symmetry. So we definitely have one, but do we have any others? There's no other way that I can fold this so that it will line up on itself. Now I've taken the time to go ahead and arrange these ahead of time so that we see this has one axis of symmetry. When we look at that X shape, we see that we can fold it in half onto itself diagonally, which means that this one is here, but there is also this one. So we know we have two. Are there any others? How about if we fold it in half top to bottom? So we have a top to bottom symmetry. And we have a left to right symmetry. So the number of axes of symmetry that this particular thing holds currently 4. But we have 4 complete axes of symmetry. Is there any other? Can we possibly line it up just off? Any other way that I try to do it, it's not lining up onto itself. And if it's not lining up exactly onto itself, we know that that's not an axis of symmetry. What about a square or quadrilateral? Because we don't yet know that it's a square. Well, I can fold it in half diagonally and turn it into a triangle. And since I can turn it into a triangle, I know that I have one axis and 2 axes. It'll work the opposite way. Top to bottom, that also works. And since that also works, I can see that it would work left to right. So once again, we have 4 axes of symmetry for a quadrilateral, or this type of quadrilateral. Now we take a look at a triangle. So we're getting into, while it's a regular shape, seeing what we can accomplish. On this triangle, I'm going to try to fold it at the axis, and I see that at the axis it does not line up exactly. But what if I fold it in half from the axis? So if I fold it in half straight down, I see that there is an axis here, but this one didn't work. This one may work. If I fold that, it doesn't line up exactly. So this particular triangle only has one axis of symmetry. How about any other types of shapes? The last shape I wanted to take a look at was a circle. So I've traced that circle, and what I have is I have my center on there just to make life a little easier to show it. When I fold it in half, I see that I can get a half circle. So that means that this will give me my axis of symmetry. But so will this. And there's an infinite number of breakdowns that I can put inside. So I can see that I have an infinite number of axes of symmetry as long as they travel through that center. So we're able to see that just using patty paper, we can figure out how many axes of symmetry there are. What if I need to know what the rotation of that axis was? Well, a 1 point has a 180-degree axis of symmetry. If I look at this where it has multiple, what I would do is I would think about this 180 degrees here. And 180 degrees is broken down into 1, 2, 3, 4 parts. So what would this be? This is a 45-degree rotation, a 90-degree rotation, 135-degree rotation, a 180-degree rotation. When would this square line up exactly on itself? So if I mark my tip, I see that a 90-degree rotation does not make the square exactly on itself. But a 45-degree rotation does not put it on itself. But a 90-degree rotation, a 90-degree rotation does. So I can see that what I've got is rotational symmetry right here of 90 degrees. To think about that triangle, if I'm looking at it and I'm trying to think about its center, if I turn it 180 degrees, it's not on itself, it only has a 0 or 360 degree rotation. But our circle has an infinite number of axis of rotations, and I can rotate it in any way. How about that X? That X shape I see rotates from, if this is my 0, if I rotate 90 degrees, where I didn't draw it perfectly, but if I rotate 90 degrees, this is a 90-degree rotation symmetry. So we have ways of finding it, and the short, easy way very often in a geometry lessons is that tracing paper or patty paper. That's why I recommend my students use it all the time.
If this video has been helpful, please like or share. And if you have any questions or comments, they go below.